Okay, another one step forward in like 2, 3, 4, 5, or 6 steps back. I've been working on my circuit. The one thing I've realized is that the speed sensor that's built into this blower motor and the speed sensor in this blower motor are vastly different frequencies. So this is on close to high speed, and the pulse coming back from the feedback signal is only 44 hertz. And if we slow it down, you should see it slow down there. A little delay here. There it goes. And that is from probably a Hall effect sensor, an optical sensor, something inside the motor. Probably a Hall effect sensor. So I went 32 hertz on this speed, which is low according to this, and 44 hertz on high. And you can hear that thing over there responds along with it, because I got the signal chain going over there. I had tunnel vision when I did that. I kind of made the circuit, moved a whole bunch of circuits around, added some of their optical isolators, which is always fucks up and makes my circuit messy. But I got it working, and then I'm using hardware pulse width modulation out to send the signal back out. Except I screwed up. 500 hertz. I need 44 hertz. So what the fuck? Then I just remembered one of the limitations using this built-in pulse width modulation is that it doesn't do low frequencies. Like, I could go down to like 500 hertz, which is pretty much what it's at, and it added a little bit to it, so that's why it's at 540 instead of going 40. Now I could kick this thing up to 30 kilohertz, whatever. It's the low frequencies that it's limited from going too low. And there's, of course, an upper threshold also, but you can't do like 60 hertz, 50 hertz, 40 hertz, anything like that. 500 hertz is like the lowest I could go, so I'm like, you dipshit. Oh, man. And the sucky thing was I took away the one pulse width modulation hardware, that this chip is capable from taking my input from the one speed and generating a totally linear variable out to this like I made the other day, restructured it, put some resistors up here that kind of do a little trick to vary the voltage out in steps, and it kind of works. So I have these 3 resistors tied to 3 outputs on my chip, and the output of your chip when it's in digital, 5 volts or 0. 0 actually pulls it to ground. When it goes to a logical 1, it pulls that to 5 volts. So if I have off, they're all pulled down to 0. If I go to low, I had it like one 10K resistor up and 2 were pulled down by the other 2 outputs, making it 5 and 10. And then when I go to medium, I had 2 10s go up and 1 down, making it 5 plus and 10 minus, your voltage resistor, taking off in the middle of that. And then at high, I just pulled them all high, which made 5 volts, which is why it's running on high. Worked fine. It was going to give me a couple speeds. That's all I cared about. Then we're going to switch along with that. It works. It works. I did all that to free up the pulse width modulator that this thing has for nothing, because the pulse width modulator doesn't go slow enough. Fuck. That's why I said one step forward, like 3, 4, 5, whatever fucks steps back. Shit. Fuck. So, that sucks. So, now I gotta do something different to make a frequency generator. And the only way that I know to do that with one of these microchips is starting and stopping timers, and you usually got to use assembler for that, and it's been a while since I did that, so man, that sucks. But so you load a value into like one of your timers, you set the scaling of the timer. There's a lot to do, and I haven't done it in a while. You load a value into your timer, and then you start it, and it goes from that value, and then it rolls over. and then it throws a interrupt flag. You have to have an interrupt handler subroutine in your assembly that it goes to, and it goes, all right, what the hell happened? And then it goes and says, okay, this thing, timer 0, rollover, interrupt flag, whatever. Now let's go turn on, and then I can have it, when it does that, jump and turn on a pin output. And then reset the timers and the interrupt flags, everything. Loads the current calculated value into there, and it starts the timer and it goes back out of that subroutine. And then in the regular programming, you have an analog digital input reading, my converted from pulse width modulated value from this, to a value in my program that's going to be the value that I load into the timer. Do some math in between so you get the right value, and pretty much it'll probably just toggle a pin each time that timer overflows, and eventually I could go with the screwdriver and probably get it to go, this voltage input is going to equal this frequency out, and then the voltage input goes down and it's going to change the frequency lower, like that. So yeah, it's going to be a lot more work. So enough of that for the night, I guess. Time to start shutting down. Damn crickets in here are pissing me off. It feels like it might actually get ready to rain out there. I don't know, but yep, that sucks something awful. Like that. Catch you guys later. Don't forget to like, subscribe, and share, and all that. I'm telling you guys, I will get this working eventually, and you're gonna see this carrier mini split head working with that Frederick bottom section, which will be my outdoor section. Stay tuned.